Welcome to Easy Math TV. Here's another statistics video on StatCrunch tutorials for inference. And we're going to continue from the previous video where I introduced you to this new distribution called the T distribution. And we had solved for these two values that you see here. The critical Z value was 1.96. The critical T value was 2.0345. And those are different, slightly different in terms of like how wide of an interval you're going to get for the confidence interval on the true mean mu. Anyway, so just to sort of put a cap on that discussion, we started with a sample size of at least 30, okay? So you wouldn't even be having this conversation if the sample size was less than 30. We would go straight to the T distribution. There would be no choice in the matter. So so as a general rule, you're going to be relying on the the T distribution a lot more for inference on a mean because you can't always make assumptions on the population unless you actually know things about the population or if your sample size is sufficiently large. Um, so the only time you really have this decision to make is when your sample size is at least 30 and your population is you're fairly certain or reasonably certain that your population is normally distributed. If you don't have those two things, then you don't even have a choice. You end up having to use the student T distribution in all inference on a mean. Okay, so I just wanted to make that clear. So the only time that you really have a choice is whether or not the value of sigma, which is your population standard deviation, is known or not. So there may be a homework question or a test or quiz question in which you are given what the sample, or sorry, you're given what the population standard deviation is, and you have a sample size that's greater than 30, and you are also operating under the assumption that the population is normally distributed. Because if that is the case, then you're going to want to use the Z distribution to make all of your calculations. Okay. If it's not, if you don't know sigma, then you're going to be using the um, T test. So whether it's a Z test or a T test is completely determined by whether or not sigma is known and whether or not your sample size is at least 30. Okay. So there's some formulas that I've typed in the screen here for you. Um, I know that when we're in StatCrunch, we don't need to be calculating these things by hand, but you never know when you might encounter a question where you need to calculate one of these things. And so I'm conveniently giving you the two different formulas for margin of error. One involves the critical T on the right. The other one involves the critical Z on the left. So notice that if we have a critical Z, we're going to be multiplying that by sigma divided by the square root of n. If we do not know sigma, then we're going to take our critical T value and multiply it by our sample standard deviation S divided by the square root of n. And that's going to give us our margin of error. And just for convenience, there are some homework questions where you are given the margin of error and you're asked to calculate the standard deviation. So for convenience, I'm giving you the formulas here for solving for either sigma or S. If you know what the margin of error is and you have your sample size and you can calculate your critical value. So sigma is equal to the margin of error times the square root of n divided by your critical z. And your sample standard deviation S is going to equal the margin of error times the square root of n divided by your critical t star. Okay. And in this situation, where we had a sample size of 34 and our confidence level is 95%, we were able to, um, you plug in your 34 for n and you plug in your critical values. And then you can see at the bottom here, you can see that all you would need to know then is your margin of error. So just plug in your margin of error and multiply by the square root of n and divide by your critical t or your critical z, and that will give you your standard deviation. Okay. So definitely write those formulas down in a notebook or something and have them handy just in case you are asked to provide information that you are not given in StatCrunch. So let's move on to an actual question here. Um, a student was asked to find a 99% confidence interval for widget width using data from a random sample with size n equals 19. And our sample mean, x bar, is equal to 18.55. And then S, which is our sample standard deviation, equals 12.342. So our goal, always keep an eye on the goal. Like write that down at the beginning of the question so that you know where to proceed. So our goal is to find a 99% confidence interval. And we have a sample size that is smaller than 30. So regardless of whether the population is normally distributed or not, we know we're going to be using the t statistic. Okay, so the first thing I'm going to do is and when we use the t statistic, we're going to get our lower limit, our upper limit, and then we can calculate our margin of error. So I want to show you how we get those numbers in StatCrunch right now. So just pause the video and write down those three values that you saw here, plus write down that it's a 99% confidence, okay? So write down your 99%, your sample size n equals 19, x bar equals 18.55, and s equals 12.342. Okay? So get those written down and bring up StatCrunch. So we're going to go to stat, and we're going to go to T stats. So T stats is where we perform all of our inference um, when we're doing confidence intervals and hypothesis testing. And we have one sample, and we don't have data, but we do have the summary data. So this is one sample T with summary data. So I'm going to go ahead and plug in my sample mean, 18.55. The sample standard deviation was 12.342. And our sample size was 19. We are not doing a hypothesis test, we're doing a confidence interval, and our confidence level is 0.99, and I'm also going to just click the box that says to show the critical value, and I'm just going to hit compute. So notice our degrees of freedom there. DF is 18, that's one less than our sample size. And in case your question asks for it, there's our standard error, which is 2.831449, which we're going to run it only. We are going to want to round that to whatever the question asks us for. And we were rounding our lower limit and upper limit to one decimal place. So the lower limit is 10.4 and our upper limit is 26.7. So if I bring this document back up, there you can see LL equals 10.4, UL equals 26.7, and then I calculated the margin of error to be just subtract those two numbers and divide by 2. So there's a question here that we want to answer as well. Which of the following is a correct representation of the estimation interval? So there's going to be a bunch to choose from here. Which of them is a correct representation? So the ones that are correct are going to be highlighted in purple. So let's look at A. A says the population mean mu is inside the range of 10.4, comma 26.7. So that's called interval notation. But is that a correct statement? And the answer is yes, that would be correct because it is a statement about the true mean mu. If we look at statement B says 10.4 is less than X bar is less than 26.7. That is not correct because we know what X bar is. We're not estimating X bar, we're estimating mu. So that is not a correct statement. When we go to C, statement C says mu is 18.55 plus or minus 8.15. And if you recall, 8.15 is our calculated margin of error, and 18.5 was our point estimate X bar. So that is also a correct way of stating our confidence interval. 18.55 plus or minus 8.15, which is basically X bar plus or minus your margin of error. And we're stating that mu is somewhere inside that interval. When we look at the last statement, we're saying 10.4 is less than mu is less than 26.7. Again, since that is actually a statement about mu and that is your upper and lower limit, that would also be a correct way of expressing our confidence interval. So um, interval notation is A. Like, so if you see a question that asks you to put your answer in interval notation, that would be the way you see the answer in A. And we're going to stop there, and then I'm going to have one more video, and we're going to do a couple more examples, and then we will be done with confidence intervals, and then we're going to move on to hypothesis testing. Like, subscribe, comment down below if you have any questions, and share these videos with other people that you think might find them useful. I'll see you in the next video.